So we're gonna do this problem. It looks more complicated than what it actually is. So first we start off with what's given. They tell us that the current for this 8 ohms resistor is 0.5 amps. With that information, we can calculate the voltage across this line right here, this resistor. What we know about parallel circuits, though, is that the voltage is the same across parallel resistors. So the voltage for this one up here is also going to be 4 volts. So we can calculate the current going through that one using that information, and that's going to be 0.25. Then we can calculate so parallel resistors can collapse and form one resistor. And this we can do by using the R equivalent, right? The resistor equivalent. And that's going to be 1/16 in a parallel circuit. It's going to be 1/16 plus 1/8, which is 3/16. So your R equivalent is going to be the inverse of that, 16/3, which is 5.33 ohms. And then we do the same for the bottom part, right? So we do 1/R equivalent resistor, which is 1/6 plus 1/2, which is 4/6. Inverse of that is your R equivalent, and that's going to be 1.5 ohms. Okay, next up. So next up, I just redrew the circuit again, but this time with the collapse resistor with my R equivalent here and my R equivalent here. Now there's 2 resistors and they're in a series. They're right next to each other. So you can just add these up and you get your R equivalent to be 25.3 ohms. The current going through the 2 is the same since they are in a series. They share the same current. So my I is going to be 0.75, which is my 0.25 that I calculated here, plus my 0.5. So this is the amount that's going in through these is 0.75. So when they collapse, it's 0.75. Okay, so then, so I found that. Then using that information, I have my current and I have my resistor, I can find total voltage across here. So what does that tell us? Well, what do we know about parallel resistors? This is now a parallel resistor to this one. So we know that the voltage across this one is going to be the same as the voltage across this one. So this is also 19 volts. Okay. Okay. So now we're not looking for we're not looking for this for 1.5. We're not looking for the resistance equivalent. We're looking for the charge that goes in to this one. Okay. So instead of plugging in this 1.5, I'm going to plug in this 2 ohms, which is what we're looking for, because we know that 19 is going to be the same for this one and for this one. Okay. So 19 volts is equal to my current times my resistor, which in this case is 2 ohms. And my current ends up being 9.5 amps at that point.